Hello and welcome to Empowered Learning. This video will be about applications of linear equations, aka we'll be solving word problems where what we're modeling will be modeled by linear equations. So I'm going to go through several examples in this video, and as I go through each example, I'm going to explain the basic principle or the thing that we're going to be modeling, and then use that to be able to help us figure out the answers to each question. So let's start with our first example. So Kendall borrowed money from her father at 5% simple interest. Key phrase here is simple interest, to help pay tuition at a local university. At the end of 1 year, she owed a total of $1,365 in principal and interest. We want to know, how much did she borrow? So the main thing here in this problem is that we are trying to model simple interest. So we need to talk about that for a second. Simple interest is a situation like if I say I'm going to let you borrow $100 at 10%, how much interest are you going to pay on that if you pay me back in 1 year? So the simple formula for that is interest is equal to principal, which is your initial amount that you borrow if you're borrowing, or the initial amount that you lend if you're the lender, your rate times the time. And in simple interest problems, the time is always assumed to be in years unless otherwise stated. And your rate, R right here, is a percentage, but we always express this in decimal form. So for instance, this will be expressed as 0.05. Now, with that being said, we also see that the accumulated amount after we borrow and we pay interest on it, and I'm just going to call that A, accumulated amount will be the principal, which is what we initially borrowed, plus the actual interest. Now, if we take into account that interest is just PRT, then you'll see that this actually ends up being P plus PRT. And if we factor out the P, or the principal, we end up with A is equal to P times, in parentheses, 1 plus RT. And so this is what we're going to use to be able to model and figure out how much did Kendall borrow initially. So what we know here is that principal plus interest is $1,365, because that's what we're told here. We know that, of course, this is the accumulated amount, but this is also equal to P plus 1 plus RT. Okay? And, of course, what we want to know here, P is the initial amount borrowed. So now we have to figure out what is going to be our rate and what is going to be our time. Well, let me rewrite this here just to be clear. We know that our rate is right here, the 5%. We also know that our time is 1 year, so T is equal to 1. So if we take that into account here, we'll see that 1,365 is equal to P, which is what we're looking for, 1 plus, and then our rate is 0.05 times 1. And thus, inside of parentheses, we know that 0.05 times 1 is just 0.05. And if we add 1 to that, that is 1.05. And so now we just need to solve for P. And that will, we will just need to divide both sides by 1.05 to be able to do that. Okay, so I'll just go ahead and do that here. So just divide both sides by 1.05. And that reduces to 1. We just have P by itself. So we see here that if we take 1,365 divided by 1.05, we'll end up getting 1,300, which of course we know that's in dollars. So it turns out here that Kendall initially borrowed $1,300. And whenever you're doing word problems, we want to make sure that we define the variable that we're looking for and that we state our answer in a clear and complete sentence. So those are requirements of word problems, so that we're effectively and clearly communicating what it is that we initially were looking for. We show our reader that, and we express that answer in a normal way. So for our next example, this would be an example to where we use some geometric shapes to be able to model whatever it is that they're asking for in this problem. So we have Zalri's nursery is a plant nursery that has a rectangular test plot with a perimeter of 322 meters. The length is 25 meters more than the width, and we want to find the dimensions of the plot. So first thing that should jump out at us is that we're talking about something that looks like a rectangle. Okay, so we're going to come draw our rectangle. We know that this word perimeter here, perimeter is just defined as sum of all sides of a shape. Okay, so it doesn't matter what that shape is, however many sides that shape may have, we add up the lengths of all those sides, and that's what the perimeter is. And just to extend that idea, a circle doesn't necessarily have a side to it, but if we measure the distance or the length around the circle, that's called circumference. So in terms of a circle, the perimeter of a circle would be its circumference. So here we have, we're going to call this a length, a width, a width. Okay. And so if we add up all these sides here, we see we have two widths and we have two lengths. So we know perimeter, and we'll just call it P, is equal to 2L plus 2W. Okay. Where of course here, L represents length, W represents width. Now we're told that this perimeter here is going to be equal to 322 meters. So here I'll just put P is 322 meters. We also know that the length is 25 meters more than, which is addition, the width, W. So we'll say that this is 25 plus W. So with that being said, I'll go ahead and also put that here. Don't necessarily have to, but I'm just doing it for visual. And so now we have pretty much everything that we need. So we know our perimeter here is 322. So therefore we can say 322 is equal to 2L plus 2W. And we know that length as expressed in terms of width. So we can say this is 25 plus W is equal to 2W here, 322. And so now from here, we just need to solve for W. Okay. Now, before we get to that, notice that this says find the dimensions of the plot. So if we're going to find the dimensions, our dimensions is going to be length by width. So we're going to need to find both the length and the width. So once we find out what the width is, we're going to add 25 to that to find the length. So carrying on with our problem here, let me clean this up. So if we distribute 2 to both terms there, we'll have 50 plus 2W plus another 2W. And that's equal to 322. 2W plus 2W is 4W. And then from here, we can subtract 50 from both sides. So that cancels. And we'll just have 4W on the right side. On the left side, this will end up being 272. And then we just divide both sides by 4. Of course, on the right side here, this will reduce to 1. And on the left side, if we go ahead and divide 272 by 4, we end up getting 68. So this will be 68 is equal to W. And of course, everything is in meters, so this will actually be meters here. So therefore, our width is 68 meters. I'm going to write that a little better here. So if that's the case, then our length is going to be 25 plus 68, and that'll end up being 93 meters. So here our answer is the dimensions of the nursery are 25 meters by 93 meters. Oh, sorry, 68 meters by 93 meters. And put a period there. Okay. And so that's how we deal with that type of problem. So we'll go ahead and move on to the next example. All right, so for our next problem, what we're going to do is figure out if a person has a choice in between two different types of salaries, how much extra work or how much commissions or monthly sales they would have to generate in order to have those two salaries to be equal. So we see here we have Juliet has a choice in between receiving a monthly salary of $1,800 from Furniture by Design or a base salary of $1,600 and a 4% commission on the amount of furniture or sales she actually makes during the month. For what amount of monthly sales will the two choices be equal? So we know here that we basically have two choices. So I'm going to put choice 1 pay and choice 2 pay. And I'll abbreviate it. We'll just leave it like that for now. So we know that choice 1 pay is just straight $1,800 a month. We know that choice 2 pay is a guaranteed $1,600, but in addition to that, we have 4% of furniture sales. And so what we need to do is figure out when these two things are equal. In order for us to know when these two choices as far as your salary or pay is concerned are equal, the one thing that we need to know is the amount of furniture sales. So here we're going to define the variable that we need to know, which is dollars of furniture sales per month. So now that we know our goal here is to have choice 1 pay equal choice 2 pay. And when we do this, for choice 1 pay, of course, this is just going to be $1,800. For choice 2 pay, we have the 1,600 plus our 4%. We translate that into a decimal. We know the word of in mathematics implies multiplication. And then, of course, we have furniture sales, the amount. That is what we are looking for. So now that we have that, we just need to find out what X is. Okay. And if we find out what X is, then we'll find out what amount of monthly sales is needed for the two choices to be equal. So from here, we'll just subtract 1,600 from both sides to start off with. Cancels. We just have 0.04x here, 200 here, and then we'll divide both sides by 0.04. Okay. And if you do this, notice that 0.04 is the same as 4 divided by 100, or 4 100ths. Okay. So here, if we're not using a calculator, we could divide this complex fraction as just saying 200 over 1 times 100 over 4, or keep change from division to multiplication and then flip this fraction. So from here, I know that 200 divided by 4 ends up being 50. So I'll reduce that. And then 50 times 100 ends up being 5,000. So we see that X here is equal to 5,000. And thus the last thing that we need to do is state our final answer here in a sentence. So we'll say here, monthly sales must be 5,000 per month for both salary choices to be equal. And you can state that in another way, but the main thing is just to know that you need $5,000 in monthly sales in order for those two things, or two salaries, to be equal to each other. So you can, again, state that in whatever way you like. So for our next example, another geometry type problem, but for this problem, we'll be dealing with a triangle. And one of the basic things that we know about a triangle is that the sum of all the angles in a triangle has to be 180 degrees. And so we're going to use that to help us out to be able to model this problem. So in a triangle ABC, and I'm just going to name it this way, angle B is going to be 5 times as large as angle A. So I'll just go ahead and write that. Angle B is 5 times the measure of angle A. The measure of angle C is 2 degrees less than angle A. So angle C will be 2 degrees less than angle A. So angle A, take away 2. We want to find the measures of angles A, B, and C, knowing that the sum of the measures must equal to 180. So here we know that angle A is the unknown. Trying to get that equal sign to come out right. Okay, so this is just basically angle A measure. And to make this simple, we'll just keep it like that. So we know that when we add up all three of these angles, angle A, angle B, angle C, have to end up equaling 180 degrees. Angle A is the unknown, so just go ahead and put that for the variable. So once we find that, we can find everything else. So everything is going to be written in terms of angle A. Angle B is 5 times angle A. And angle C is going to be 2 degrees less than angle A. And so from here, I could literally drop these parentheses here because all we're doing is adding and subtracting. There's no multiplication going on. So here I'm just going to combine like terms. So I have angle A, 5 times angle A, plus another angle A. That will give me 7A, or 7 times angle A, minus 2 degrees equals 180 degrees. So here we can add 2 to both sides. And we end up getting 7 times angle A is equal to 182 degrees. So then from there, we'll just divide both sides by 7. Turns out here that that ends up equaling 26 degrees. So we come here, if angle A is 26 degrees, then we know that angle B is going to be 5 times that. And that'll end up being 130 degrees. And angle C is going to be 2 degrees less than this, which is 24 degrees. And so we'll say here that the measures of angles A, B, and C are 26 degrees, 130 degrees, and 24 degrees respectively. So our next problem will be an investment type problem. And so this problem again will sort of showcase simple interest, but it'll showcase it in the, I guess, opposite direction. What I mean by that is with simple interest, you can either use simple interest to calculate how much you owe, or you can use it to calculate how much you are owed. And that depends on whether you are the borrower or the lender. Okay. In the other problem that we did earlier in this video, we were acting as the borrower. So now what we're doing in this example is we're acting as the lender. And of course, if you're lending the money, then it is an investment for you. So we see here that Erica has invested a total of $5,000, part of it in a 3% simple interest investment, and another part into a 4% simple interest investment. Okay. And at the end of 1 year, that investment earns $176 in interest. And so what we want to know is how much of this $5,000 went into both the 3% simple interest investment and the 4%. Okay. So just by reading through that one time, the main thing that we got out of this is that there's some interest that is earned on the 3% investment. There's some interest that is earned on the 4% investment, and that result came out to be $176 in interest if we lend that money out to that investment for 1 year. So what we need to do now is characterize what is going on with the interest for the 3% investment as well as the 4%. So for the 3% investment, we know that, again, I is equal to PRT. So here, P will be the initial amount in 3% investment. And that we don't know, so we'll just call that X. Okay. or we could, leave it as P if we want, but I'm just going to call it X this time. The interest rate is 3%, and that is going to be 0.03. The time is going to be 1 year. For the 4% investment, we know that whatever amount of the 5,000 is not in the 3%, that has to be in the 4%. So here, that would be 5,000 minus X. Because again, whatever is not in here of the 5,000, the remainder of it has to be here. The rate is going to be 4%. And of course, the time again is going to be 1 year. So when we look at all of this and we put it together, we'll see that the interest for the 3% investment is just going to be I equals PRT. So that's just going to be X times 0.03 times 1 plus, same thing for the 4% investment, 5,000 minus X for the P, 0.04 for the R, and then 1 for the T. And of course, all of that is equal to $176. So cleaning this up and making it look a little better, we know that we'll have 0.03x and here 1 times 0.04 is just 0.04, so we're literally just going to distribute and here if we do 1% of 5,000, 1% would be 50 because 10% of 5,000 is 500. 1%, move the decimal place over, is 50. So 50 times 4 is 200. So that would be 4% of 5,000 minus the 0.04. And that will be equal to 176. And this should be an X here as well. So now we combine like terms. So these are like terms. So we'll have 0.01x plus 200 is equal to 176. And then we'll subtract 200 from both sides. That cancels. We'll just have negative 0.01. Get that looking a little better. So this ends up being 24 here. And that'll be negative. And then after that, we just divide both sides by 0.01. Or negative 0.01, I should say. And the pen is dragging for some reason. Hopefully we'll work it out. So here we know that on the left side, that's just X because these numbers reduce to 1. And here we know that we could look at this by taking the decimal and moving it over 2. So if we do that, that would be a negative 1. But we have to do the same thing here. And that would be 2,400 like that. So our final answer here would be 2,400. And of course, that is in dollars. So now that we know that, if X is 2,400, then that means that 5,000 minus X, or 5,000 minus 2,400, that is going to be 2,600. So our final answer is that we know that 2,400 went into the 3% investment, and 2,600 went into the 4% investment. So that would be how you would properly answer that question. So for the next few problems that we're going to do, they're going to entail using the relationship of distance is equal to rate times time. So with this first problem, we see that Angelo has a kayak, and that kayak is traveling at 14 kilometers per hour in still water, meaning water that's not moving. Okay. If the river's current flows at a rate of 2 kilometers per hour, how long will it take him to travel 20 kilometers downstream? Okay. So the first thing that we need to think about here is this kayak and the river and how everything's flowing. So if I got a river here that's flowing, and let's say I got a kayak here and it's going downstream, it's going at a certain rate. So I'm just going to say that this is rate of the kayak. One of the general principles that we know about the flow of rivers is that rivers always flow downstream. Okay. So since the current, the river's water current is at a rate of 2 kilometers per hour, since rivers water flow downstream, that is also going to be going down as well. So really shouldn't have a point there, but do it like this. So the rate of the water. So we'll say this is going to be the river current, and this is going to be rate of kayak. So the one thing that we see is that they're both going down, so that means that the total rate that the kayak will eventually be traveling will be what it is in still water plus whatever the current flow rate is for the actual water. So it's going to be going faster than normal. We know that our distance here is 20 kilometers. So when we look at this, we know that distance is equal to rate times time. We know that our distance will be 20 kilometers. Our rate is going to be a sum of the rate of the kayak plus the rate of the water. And then our time is the one thing that we need to find out. Okay, so time is going to be time to travel 20 kilometers downstream. And so here we know that the rate of the kayak was 14 plus the rate of the actual water is 2. Of course, that is just 16t on the right, 20 on the left. We'll divide both sides by 16. These reduce to 1 and we just get t. And of course 20 and 16 both have a common factor of 4. So 4 goes into 16 4 times. 4 goes into 20 5 times. So we end up with 5/4. And since our time unit was in hours, we'll keep that in hours. For those of you that want to express it as a mixed number, that is 1 1/4 hours. And if you want to express it in decimal form, that is 1.25 hours. So we see that the kayak will take 1.25 hours to travel 20 kilometers. So for our next example, we have an airplane that travels 450 miles per hour in still air, and it encounters a 30-mile-per-hour headwind. And of course, a headwind means that the wind is blowing against the plane. So if the plane is traveling in one direction, the headwind is blowing in the opposite direction, creating resistance for the plane. Okay. So we know that, and I'll just draw the plane here right quick. And we know that that rate is 450 miles per hour. And we have some headwind coming this way. That's 30 miles per hour. Okay. And we want to know how long it will take the plane to travel 1,050 miles into the wind. Okay. So we're doing this, and let's say it travels this far. The main thing that we know again is that we're given a distance, and that this rate and this rate are working against each other. So that means that the aggregate rate is going to be, let's say, this 450 minus the 30, which will be 420. Okay. So we're going to call this the net rate here. It's going to be 450 minus 30, which is 420. That's in miles per hour. So looking here again, we want to know how long it will take. So we want to know time, plane to travel is 1,050 miles. Distance is equal to rate times time. Our distance is 1,050. Our rate here will actually be our net rate, which would be 420. And of course, time is the one thing that we're looking for. So here we divide both sides by 420. C, that reduces to 1, and we just get t. We know that this fraction here will reduce to 105 divided by 42. And here, if I was to actually divide 105 by 42, I'll just go ahead and do it here on the side. We know that 42 goes into 105 two times. 2 times 42 is 84. We end up with 21 remainder. And so, of course, we know 21 is half of 42. So this would be like 2 and 21 over 42, or 2 and 1/2, or 2.5. Okay. And of course, our time unit is hours. So this would basically be 2.5 hours. So we'll say we'll take the airplane two 2.5 hours to travel 1,050 miles. So this next example that we have is an example of what we call a mixture problem. And so this problem says how many grams of 60-40 solder, meaning that 60% of that particular solder is made out of tin and the other 40% is lead. We want to know how many grams of that must be mixed with a 40-60 solder, meaning that we have 40% tin in this mix and 60% lead, so that we can get 600 grams of a mixture to where we have 55% tin and 45% lead. Okay. Now, the first thing that we notice here is that we have a total of 600 grams in this final new mixture that we're trying to come up with. Okay. And it's coming from the 60-40 solder and the 40-60 solder. So here we know that the 600 grams of 55-45 solder has to be a combination of amount of 60-40 solder and the amount of 40-60 solder. Okay. So since we want to know how many grams of the 40-60 solder, we're going to let that be our X. Okay. So we'll start off with X being number of grams of 60-40 solder. Now, whatever amount we have here, X, of the 60-40, since we have to have a total of 600 grams, the remainder of that will actually have to be from the 40-60 solder. So here my point is that if we have a total of 600 grams and we use X grams to have a 60-40, then it's going to be 600 minus X, which is going to be the number of grams of 40-60 solder. Okay. Now, when we go to try to figure out how much of this solder we're going to have here, notice that we're given percentages based on the different types of solder. And so what I'm going to do is just use the information from just the 10 in each one to make my point. So if we remember here, this 40-60 solder here means that 40% of this is tin and 60% of this is going to be lead. So just looking at the tin only, I know that 60% of whatever this 60-40 solder is just going to be tin. So 60%, that's 0.6 times X. Plus, I know that for the tin, I have 40% here, which is 0.4. And of course, the 40-60 solder, that amount is going to be this 600 minus X. So I know that 60% tin from the 60-40 plus 40% tin from the 40-60, that is going to have to equal 55% of the 600 grams. So that'll be 0.55 of 600. Okay. Now I could come up with another equation doing the same thing for the lead. Okay. So I'm not going to use that to solve this, but I just want to state this so that you can see we can look at it the same way. So here, if I kind of look at it from this perspective here, I know that if 600 minus X is going to be the amount of 60-40 solder that I have here, then I could say starting here, I'll have 60% of the amount of the 60-40 solder plus 40% of the amount of the 60-40 solder. So here this was the 40-60 and here's the 60-40, and that would have to be equal to 45% of this 600. I could use either one of these equations to come up with what my value for X would be. Okay. I think I'll do here is just use one to show you that we get the answer, and then we'll use the other to see that you can get it that way as well. Okay, so we'll use the 10 one first. So if I come here, trying to do some separation here, so 0.06x plus, and we distribute. Here we see that 600, if we do 10% of 600, that's 60. And so 40% would just be 60 times 4, which would be 240, minus the 0.04x. And then after that, if we do 55% of 600, we know 50% of 600 is 300. And then, of course, another 5% would be half of 10% of this. And 10% of 600 is 60, so half of that is 30. So if we add that, that's just 330. And so now we just use this to solve for x. So 0.6x minus 0.4x gives us 0.2x plus 240, and that will equal 330. From here, we subtract 240 from both sides. Cancel. And then from there, we end up getting difference in between 330 and 240 is 90. Divide that by 0.2. And 90 divided by 0.2 is the same as saying 90 divided by 2 divided by 10. Which, if we express that in fraction form, will look like this. So keep, change, flip. And of course, 10 divided by 2 is just 5. And 5 times 90 is 450. And of course, this is in grams. So we know that it'll take 450 grams of the 60/40 solder in order for us to be able to get a mixture that of the 600 grams of 55/45 solder. So now that we've checked this with the tin, I'm going to do the same thing with the lead to show you that we end up with the same answer here. Okay, I'm going to erase some of this so that I can work this out again. So now, using the lead equation, we will go ahead and distribute 0.6 both terms here. And so in doing that, we know that 60% is actually 50% plus 10%, and 50% of 600 is 300, plus another 10% of 600 is 60. So that would be 360 here, minus 0.06x plus 0.4x, and this would equal 45% of 600. We know that 50% of 600 is 300. Pen's not working there. But we know that we would have to subtract 5% from that. And of course, 10% of 600 is 60. Divide that by 2, that's 30. So we have to take away 300 minus 30, which would give us 207. And so now from here, we would combine like terms. So negative 0.6x plus 0.4x is a negative 0.2x. I have 270. And then we will subtract both sides by 360. That cancels. And we just have negative 0.2x. And 270 minus 360 is a negative 90. Divide both sides by 0.2. And you can kind of see that we're ending up with the same thing that we had before. And of course, negative divided by a negative is a positive. And 90 divided by 0.2, again, we know that ends up being 450 grams. So final answer here is going to be, we need 450, and that 4 didn't turn out fine. So we need 450 grams of the 60/40 solder to have 600 grams 5545 sorry. So our last example will be a work rate example. And so this example says we have a new letter sorting machine, and it works twice as fast as the old one that they currently have. Both sorters working together complete a job in 8 hours. We want to know how long would it have taken the new letter sorter to do the job alone or just by itself. So the first thing that we realize here is that this is a time thing, but we're not given the actual time for each separate sorting machine, meaning the new one or the old one. Okay, so here, since we don't know what that is, the only thing we know is the relationship in between the two, we're going to have to write that as a variable. So we'll start off by letting x equal the number of hours the new sorting machine sorts letters. Okay, and we'll let 2x be the number of hours for the old machine to sort letters. Okay, so we'll start off with that. Now, one of the things that we know is that, and I'm just going to put some numbers in this for just a second. So let's say it took the new machine 10 hours to do this job. Okay, so that means it would take the old machine 20 hours to do the job. Now, looking at this linearly, if it takes 10 hours for the new machine to do the job, then how much of this job would be done in 1 hour? Okay, and so of course that would end up being 1/10 of the total amount of letters that you had would be done in 1 hour. Okay, so we don't know, how many letters it is, but we know that if it takes 10 hours to do it, if we just looked at 1 hour, 1/10 of that should be done if everything is linear, if done in a linear fashion. Same thing here. If we had a total of 20 hours it took for the old machine to do it, then of course after 1 hour, 1/20 of it should be done. Okay, so since we understand that, then what we're going to do in this case is look at it and say, all right, well, what portion of the letters are done if it is X hours? And of course, the portion that will be done in X hours would be 1/x of it. Okay, and the same thing here. So if we wanted to know, hey, if it takes 2 times X to do the whole thing, then it's going to take 1 divided by 2x to be able to see how much we are actually finished with within an hour's time. So because of that, I'm going to go ahead and erase all this. We need to define some other variables here. And we're going to say, because of this, 1 divided by x is going to be the portion of letters sorted in 1 hour's time. And here, 1 over 2x is going to be the portion of letters sorted in 1 hour's time. Okay. Now, the other thing that we know is that we know that the time that it takes for the letters to be sorted with the old and new machine working together, that time is 8 hours. So here I'm going to let that be T, which is time to sort letters, new and old machine together. So that also implies here that how much of this would be done in 8 hours that's 8 hours, then 1 over t, which is the portion of letters sorted in 1 hour, that should just be 1/8 of them. Okay. And so now what we're going to do, since we're trying to figure out how long would it take, okay, our variables here are going to be x, but we know that the portion of the letters that's done in 1 hour plus the portion of the letters that's done in 1 hour for the new machine and the old machine, if we were to add those things together and then make it equal what we have here, which is going to be 1/8 of this, then we would be able to find out what we need. However, notice that we know the total time that it takes to do these things together. And so because of that, what we need to do is add that factor into what we're doing. So my point here is this. Normally, if this was, let's say, 1 hour, then our equation here would be just 1 over x, 1 over 2x, and that would equal 1. But because of the fact that it's actually 8 hours, all of these are going to increase by a factor of 8. And so here we essentially have this. And so our new equation, because of this, will end up just being 8x plus, and if I distribute here, this would end up being 4 divided by x. And let's see here, this would still end up, well, actually that would still end up being 1, because I would have 1/8 here. Sorry. I was supposed to put 1/8 here and then multiply by 8. So that ends up being 1 there. So here we see that once we have that, then that's just 12 divided by x equals 1. And of course, if we do cross multiplication, that just ends up being 12. And of course, all this is in hours, so it's going to take 12 hours for us to put this all together. Now, normally, if you look at this in a textbook, they will give you a chart to kind of piece this together. But one of the things I wanted to do is to kind of take a different approach and sort of colloquially talk about it so that you can see how all of that is formed. And so I'll review just to make sure that everyone follows along. So if we know that x is the number of hours that it takes to sort letters, and the old machine takes twice that, then the portion of the letters done for the new machine should be 1 divided by x if in 1 hour's time. Same thing for the old machine. 1 divided by 2x should be the portion of those letters done. Okay. Now, the time to have the new and old machine work together to get those letters sorted is going to be 8 hours, and I'm calling that t. So that means that 1 over t here would be the portion of letters done within 1 hour time, which would be 1/8 of that. Okay. So again, if I was to ignore the fact that, hey, I got 8 hours here that it takes for those things to work together, my original equation would look something like this. Okay. Look something like this. Now, the fact that I could actually solve this equation just using that, but we want to use the fact that, hey, it's taking 8 hours to do everything, because we want to figure out, well, on this side here, if we multiply this times 8, then what that means is that, hey, if we do 8 of these 1/8, then it means that the job is completed because 8/8 of the letters are sorted. So here we could do the same thing on this side. Now, from equation solving standpoint, I would want to multiply both sides by 8 anyway, because I would want to get rid of this fraction here. Okay. In all actuality, if I was actually just doing this and doing like regular equation solving, I'll show you how I would actually do this, and we should still come out with the same answer here. So let me just erase this to make this point. So if you're okay with just saying, all right, well, I just want to use this and this and add it up to be this, that's totally fine. Okay. So here in this case, I would have to figure out, well, what's going to be the least common denominator in between 8, 2x, and x. Okay. And so for that, the least common denominator would actually be 8x here. So I would literally come here and multiply numerator and denominator by 8x. If I did that, my equation is going to look a little different, but the answer is still going to be the same. So when I distribute here to both terms, I'm going to have 8x divided by x, which is just 8, plus here I'm going to have 8x divided by 2x, which is just 4. And here I'm just going to have 8x divided by 8, which is x. And of course, 8 plus 4 is 12. And you see that I end up getting the same answer there. Okay. So the way that your textbook, depending upon where you're taking this course, your textbook will probably do it the first way. I personally like this way here because once you're at this point, you can just use, hey, this portion of letters for the new machine will be done here. Portion for the old machine equals portion done in 1 hour if it was done together. And then you can just use your equation solving techniques to get to your final answer there. Okay. And so again, we would write this final answer in sentence form. And basically we would say it would take the new letter sorter 12 hours to sort all the letters by itself. So it would take 12 hours for the new letter sorter to sort these letters alone. So that's how we would end up doing this problem. So hopefully this video has been helpful in showing you how to go about solving some application problems that involve modeling these situations with linear functions. And so again, let me know if you like this video. If you need any clarifications, just leave some comments and I will get back to you as soon as I can. Thanks. Take care.